Okay. Very good afternoon. See, I'm starting the session. Listen. So in the previous session, very clearly we discussed about views. So view means it is a virtual table that does not contain any physical data and does not occupy the memory. Just it holds the select query. If we retrieve data through the view, it runs select query. So some views can be updated. Those are called updatable views or simple views. Some views cannot be updated. Those are called read-only views or complex views. If view is created based on one table, simple view. If the view is created based on giants or subqueries or group by or having, etc., that is called complex view. So till here very clearly we discussed. And next database object is index. Indexes. Topic name is indexes. So what is index? So this index is a database object like table, view. This is also one database object. Then what is the purpose of index? Try to understand. Listen carefully. See here. For example, see, in the textbooks, in the books, indexes will be there. So publisher is providing. Index to us. So in the book, they are providing index. For example, if you have Oracle book, in the front page, they provide index like this. Okay, here chapter name, they write in first column. In the second column, page number, like this, they provide the index to us. For example, chapter name is SQL commands. Okay, this chapter is in 10th page. Okay, chapter name is built-in functions. This chapter is in 20th page. Okay, chapter name is classes. This is in 40th page. Chapter name is giants. This is in 60th page. Chapter name is subqueries. Okay, this is in 70th page. Like this, they provide index to us. Okay, so see here. So in the books, they are providing index. Okay, why they are providing index? If this index is not provided, what happens? It becomes lot of time. It takes lot of time to refer particular chapter. For example, assume that you are referring one Oracle book. This index is not available. You want to refer giants chapter. If index is not there, what you have to do? Every page you have to check. Where is giants chapter? So it takes lot of time. So if index is there, what you will do? Directly you open the index. In the index, where is giants topic? You will search. So directly you go to the 60th page and you refer the topic. So if index is not there, it is taking lot of time to refer giants topic. If index is there, directly you are referring the index. You are going to that page and you are referring the topic. So searching every page takes lot of time, or using index takes lot of time. Searching every page takes lot of time. So which one is the best way? Index or searching every page? Index is the best way. So that's why they are providing the index. So if you understand this point, easily you can understand SQL plus indexes. Very, very easy. So in the textbook, they are providing the index. If this index is not there, if you want to refer this Jan's topic, you need to check every page. It takes a lot of time. But if index is provided by the publisher, directly you open the first page, you refer the index. So Jan's chapter is in 60th page. So directly you go to the 60th page and refer that Jan's topic. So if you are searching every page, it takes a lot of time. If you use index, quickly you can refer this Jan's topic. In the same way, in the table also, see, there are two types of scans. When we submit the query, it may perform table scan or index scan. See here. For example, I'm writing like this. Select e-name, salary from EMP, where salary greater than 3,500. Like this, I'm submitting the query. So when we submit this query, assume that our frequent operation is retrieving data based on salary values. Assume that our frequent operation is retrieving data based on salary values. So salary greater than 3,500, salary greater than 5,000, salary less than 2,500, okay, salary greater than 10,000, salary less than or equals to 8,000. Like this, our frequent operation is retrieving data based on salary column. If our frequent operation is retrieving data based on salary column, to improve the performance, it's better to create the index on this salary column. So in the where class, which column we frequently used, on that column only we create the index. If our frequent operation is retrieving data based on salary column, it's better to create index. Okay. For example, when we are submitting this query to the Oracle, Oracle may perform either table scan or index scan. There are two types of scans. When we submit query like this, Oracle may perform either table scan or index scan. We submit this query to the Oracle. So now Oracle may perform either table scan or index scan. When it performs table scan, when index is not created, if index is not created, which scan it will perform? Table scan. Okay. So this is just like this one. If this index is not there, if we want to refer Jan's topic, what we do? We check every page. This table scan is just like checking every page. This table scan is just like checking every page. It takes a lot of time. Every record that has to check salary is greater than 3,500 or not. On every record, this condition should be applied. So it takes a lot of time. If the table has 10 rows, 10 conditions it has to check. If the table has 100 rows, 100 conditions it has to check. It takes a lot of time. Table scan is slower. If index is created, that will perform index scan. So if index is created, it performs index scan. So this index scan is faster. Index scan is faster. This index scan is faster. Whereas table scan is slower. Table scan is slower. So table scan is slower, index scan is faster. So for example, see here, this index is not there in the textbook. To refer Jan's topic, every page we will check. That is just like table scan. So if index is created to refer the Jan's topic, in the index we are referring this topic, we are identifying the page number, we are going to that page and we are referring. This is just like what? Index scan. Okay. So in the table scan, on every row condition will be applied. Whereas in index scan, one B tree will be created. Okay, so there less comparisons will be done, less comparison will be done than table scan. So index scan improves the performance. The main goal of index is improve the performance of data retrieval. Remember this. This point is important here. That's it. This is the overview on index. So I'm writing these points only. Observe. So what is index? Index is a database object like view, like table. This index is a database object. This index is used to improve the performance of data retrieval. So to improve the performance of data retrieval, we create the index. To improve the performance of data retrieval, we use the index. So to refer a topic in book, to refer a chapter or a topic in book, we use index in the book. We use index in the book. So we use index in the book. So why we are using index in the book? So with this index, we can refer the topic quickly. So with this index, we can refer the topic. We can refer the topic quickly. By identifying the page number, directly we go to that page number. So if this index is not there, it takes a lot of time. In the same way, to retrieve data, to retrieve record in a table, index is used. Okay, to retrieve the record in table faster, we use index. That's it. So to refer a topic quickly, we are using index in the book. In the same way, to refer a record in the table faster, we use index. If index is not there, it takes a lot of time. If index is there, quickly we can retrieve that record. So we create indexes on columns. Index will be created on particular column or columns. Index is created on column or columns. So to retrieve record in table, okay, if you want to retrieve the record in table faster, we use this index concept. This index we create on column. On which column we create this index? The columns which we frequently use in the where class. The columns which we frequently use in where class. The columns which we frequently use in where class, on them we create the index. So the columns which we frequently use in where class, on them we create the index. That's it. So it improves the performance. So these are the basic points regarding index. So if anyone is asking, what is the purpose of index? What is index? Simply you can say, this index improves the performance of data retrieval. To improve the performance of data retrieval, we are using it. So to retrieve table record faster, we use this index. This index we create on particular column or sometimes multiple columns also. So on which columns we create? the columns which we frequently use in the where clause. On them, we create the index. That's it. So, when we submit a query to Oracle, it may perform any one of the two scans. They are. What are those two scans? First one is table scan. Second one is index scan. So among these, which one is the faster one? Index scan is faster. Table scan is slower. Index scan is faster. So when table scan will be used, so if index is not created, so when table scan will be used, if index is not created, Oracle performs table scan. Okay, it is slower. So this table scan is slower. So if index is not created, it performs table scan. It is slower. It is slower than index scan. Okay, whereas index scan, if index is created on column, then Oracle performs, if index is created, Oracle performs index scan. So it is faster. This index scan is faster. It is faster than table scan. So if index is not created, it performs table scan. If index is created, it performs index scan. So index scan is faster than table scan. Table scan is slower. Okay. So is it performing index scan or table scan? We want to check. So try to understand. So first let me give the syntax to create this index. So syntax to create the index. So syntax to create the index. So we write like this: create index name. Create index name on which table, which tables, which column. On which column you are creating the index that we have to tell. That's it. Very simple. This is the syntax of creating index. Okay. So create index name on which tables, which column. On which column you are creating, that column is in which table we have to tell. Okay. Generally we create index on column, but this column is in which table we have to tell. So which tables, on which column you are creating this index, that we have to tell. That's it. For example, see here. Listen. We are writing like this. We are submitting a query. Select star from EMP where salary greater than 2,500 I'm writing. Now, you tell me, is it perform? If we write like this, is it perform table scan or index scan now? Table scan. By default, it performs table scan because till now we didn't create any index. So by default, it performs table scan only. So now table scan will be done. Okay. Now what we are doing is we are creating one index. So create index. Index name I am giving as I1 on which table? EMP table. On which column we are creating? Salary column. Okay. So now it gives message as index created. It gives output as index created. Now index is created on salary column. Now the same query we are submitting now. Now same query we are submitting. Okay, is it perform table scan or index scan now? Now it performs index scan. So if index is created, index scan will be performed. If index is not created, table scan will be performed. Okay, so what I'm doing is from the EMP table, I'm creating one more table here. Or otherwise I'm using same table. Okay. So this is the query. Is it performing table scan or index scan? If you want to see that one. Okay. So after opening Oracle screen, after opening SQL Plus, every time I'm writing like this, set page size 200. So what is this page size here? Attribute. Parameter, sorry. This page size is the parameter. So set page size 200 I'm writing. So what is that one? That is one parameter. Like page size parameter, there is one parameter is there. Like page size parameter, there is one parameter is there. That parameter name is auto trace. Auto trace parameter. By default, this auto trace value is off. So that's why it will not display execution plan. If we want to see the execution plan, we have to set auto trace as on, right? Explain here. Set auto trace on, explain. So why we are writing this? To see execution plan. To see execution plan, we write this command. So we set auto trace parameter as on if we want to see execution plan. So with this we can understand, is it performing table scan or index scan? We can understand. Observe carefully here. So I'm setting page size 200, line size 200. Observe here. Show all I am writing. So all these are what? Parameters. Show all means it will display parameters. See, we are writing show all. Show all means it is displaying all parameters. So by default auto trace value is off. So by default auto trace value is off. And by default line size value is 80. Okay, by default page size value is 14. Means in one page it can display 14 lines only. And line size means in one line it can display 80 characters only. That we are increasing every time. So I am setting page size as 200. Okay, line size as 200. Now again I am writing show all. Observe now. Previously this page size was 14. Now page size is what? 200. Previously line size is what? 80. Now line size is what? 200. So like this we can change the parameter values. All these are parameters. So among these parameters, this auto trace is also one parameter. So by default this auto trace value is what? Off. Okay. So we are setting this auto trace value as on. Explain. Why we are writing this? We want to see the execution plan. To see the execution plan, right, we have to set auto trace as on. Explain we have to write. So set auto trace on, explain. So now I'm submitting the query now. Observe here. Select star from EMP where salary greater than 2,500 I'm writing. Now you tell me, is it perform table scan or index scan? Table scan will be performed. Observe here. So what it is performing? Okay, table scan it is performing. Observe what it is telling. Entire table accessed here. So table access full it is telling. So entire table accessed. On that this filter condition applied. So entire table accessed. Okay, On this filter condition applied. On every row, filter condition is applied now. Okay. So now, what is the actual table? Actual table we didn't open. Let me open actual table. See. So select employee number, e-name, comma salary from EMP. So what is happening here is we are writing condition like this. We are writing our query as, we are submitting our query as, just a minute. So we are submitting select star from EMP or column list from EMP where salary greater than 2,500. This condition we are applying. So now this condition will be applied on every record. So is 960 greater than 2,500? It is checking. Is this condition true? False. Is 1840 greater than 2,500? False. Is 1437 greater than 2,500? False. Is 3,570 greater than 2,500? Yes. Okay. Here false. Here true. Like this on every row. On every row, it is applying the condition. If 10 rows are there, how many comparisons it is doing? 10 comparisons. If 100 rows are there, how many comparisons it is doing? 100 comparisons. So with all records, it is comparing. Okay, so this is called table scan. Every record will be scanned, compared here. This is called table scan. So by default, it is performing table scan. So in the table scan, number of comparisons equals to number of records. But whereas in index scan, not these many comparisons will be done. Very less than comparison, very less comparisons will be done. Maximum half of the records will be compared. Half of the comparisons will be done. For example, if the table has 10 records, maximum 5 comparisons. If the table has 100 records, maximum 50. Okay, sometimes less than 50 also. So that improves the performance. So now, as of now, index is not created. So that's why when we are submitting query like this, select employee number, e-name, salary from EMP where salary greater than 2,500 means it is performing table scan now. Enter table accessed. Now we are creating one index on salary column. Why we are creating on salary column? Our frequent operation is retrieving data based on salary. So that's why we are creating index here. Create index I1. Create index I1 on which tables column? EMP tables. EMP tables which column? Salary column. So on EMP tables, salary column, we are creating the index. Now the same query we are submitting now. So now, is it performing table scan or index scan? Index scan it is performing. So the same result is giving, but it works faster. This retrieval is faster. It is not performing table scan here. It is performing index scan. So inside of index, okay, values will be there. For example, 3,000 is the salary value. Its row address will be there. Okay, 4,000, its row address will be there. So it uses the index here. So directly the employee who is earning 3,000 salary that goes to that row ID and picks the record. Just like in the book that is using the index. Like that here also index is there. Here salary value is there. Okay, which employee is earning that salary? That row address is there. So it goes to the index. If that is greater than 2,500, Okay, that value, for that value, what is the row ID that identifies, that goes to that row ID and picks the record. So it will not perform all comparisons here. So index improves the performance of data retrieval. So index range scan, it is performing. So here table accessed by using the row ID. Means in the index that is identifying the row ID, that is going to that row ID and picking the record. So in the index, values and row IDs are there. Salary value, row ID. The employee who is earning 3,000 salary is row ID. Employee who is earning 4,000 salary, row ID. So here table accessed by using row ID. So who is earning 3,000, that is going to that row ID and picking the record. Who is earning 4,000, that is going to row ID and picking the record. So every record will not be compared here. In the index, the values which are greater than 2,500. So those it is giving. So index scan is faster than table scan. So once again I'm repeating, listen. When we submit a query to the Oracle like this, if index is not created, it performs table scan. If index is created, it performs index scan. In the index scan and in the table scan, which one works faster? Index scan works faster. Okay. How index scan works faster? How index scan works faster? I'm explaining. Listen carefully. Try to understand. For example, here salary column is there. Some salary values are there. Like one employee is earning 4,000 salary. One employee is earning 5,000. One employee 4,500. One employee 1,200. One employee 3,000. Okay. And another employee 4,500. Another employee 3,000. Okay. One employee is earning 1,000. One employee earning 1,500. Okay. So like this, salary values are there. So these are the salary values. And some employees are getting same salary also. Okay. So like this, salary values are there. Okay. So these are the salary values. So when we create the index, please don't make the noise with pen. Put pen aside and listen. See, when we create the index on salary column, implicitly one B tree will be created. B tree means balanced tree. One tree will be created. Maybe in your academics, you learned about data structures, in the data structures tree concept. So that tree concept will be used by the index here. Okay. So tree means tree is the collection of nodes. So when we create the index, implicitly one balanced tree will be created. When we create the index, implicitly Oracle creates balanced tree. To create this balanced tree, they have written some algorithms, some programs. That program creates this balanced tree. So B tree means balanced tree. One balanced tree will be created. So tree means, tree is the collection of nodes. When we create the index, implicitly Oracle creates the B tree. So B tree means, so tree is the collection of nodes. B tree is the collection of nodes. Okay, so nodes will be there. So node contains value and two addresses. Node contains value and two addresses. Okay. So based on some algorithm, here B tree will be created. And for B tree, there is a rule. That is, for B tree, there is a rule. That is, if value is less than or equals to root node. If value is less than or equals to root node, place it at left side. If value is less than or equals to root node, place it at left side. If value is greater than root node, if value is greater than root node, place it at right side. That's it. This is the basic rule in the tree. Based on this only, tree will be constructed. So if value is less than or equals to root node, place it at left side. If value is greater than root node, place it at right side. Place it at right side. So this is the tree principle. So based on this principle, tree will be created here. So to take the root node value, implicitly it uses some algorithm. For example, here I am taking root node value as 3000. I am taking root node value as 3000. So 3000 value we are taking as the root node value. Okay. So 3000 is the root node value we are taking. So to take this root node, implicitly that may use any algorithm, any program that may use. For example, I am taking based on this principle. What is the minimum salary here? 1000. What is the maximum salary here? 5000. I am finding average of these two. That result I am taking as the root node. Okay. So what is the minimum salary? 1000. What is the maximum salary? 5000. Find the average of these two. 6000 by 2. What is the result? 3000. This 3000 we are taking as the root node. Okay. So now, what is the minimum salary here? 1000. So this minimum salary and root node average again I am finding. 1000 plus 3000. 4000. 4000 by 2. 2000. This 2000 is less than root node. This 2000 is less than root node. So I am placing it left side. So if value is less than or equals to the root node, we have to place it at left side. So left side we are placing. And what is the maximum salary here? 5000. 5000 and this root node average I am finding. 5000 plus 3000. 8000. 8000 by 2. 4000. That 4000 I am taking as another node here. So 4000, is it greater than 3000 or less? Greater. Greater means where we have to place? At left side or right side? Right side we are placing. Okay. Now, so like this, one balanced tree will be created here. Based on some algorithm, it creates the balanced tree. So now, in this, we want to store these values. So what is the first value here? 4000. Now you tell me, is 4000 greater than root node or less? Greater than. This 4000 first salary takes that compares with root node value. So if it is greater, that will be placed at right side. If it is less than or equal, that will be placed at left side. Okay. So remember this. If that is less than or equal, that will be placed at left side. If that is greater, that will be placed at right side. Okay. So now what is the first value here? 4000. That compares with root node. Is 4000 greater or less? Greater means where it will go? Right side. Right side another node is there. Is 4000 greater or less or equal? Equal. Equal means where it will be placed? Left side or right side? So left side, it places this 400 value. And the employee who is earning this 4000, that row ID will be placed here. Okay, that's it. Very, very simple. The employee who is earning this 4000 salary. Okay, the employee who is earning 4000 salary, that employee's record ID, row ID will be stored here. Every row has row ID. To see that, we use the row ID column. Observe here. select row ID, comma employee number, comma e-name, comma salary from EFP. Observe here. So this 7369 employee Smith record stored in which ID? This ID. This is the row ID. This is called row address. This is the row address. So 7499 Allen record address is this one. This is the address. Okay. So like this, for every row address is there. This row address and that salary value. This 4000 here star means you can understand like row ID pointer. Okay, row address is there. So value will be stored and row ID will be stored here. Next, second value is what? 5000. Okay, second value is 5000 now. Second value is 5000. Is it greater than root node? Yes. So it goes to right side or left side? Right side. Again, it right side 4000 is there. It compares with 4000. Is 5000 greater than 4000? Yes. It goes to the right side. Here it places the 5000. So 5000 will be placed here. So 5000 will be placed at right side now. So here right side, it is placing 5000. 5000, it's row ID. The employee who is earning 5000, that row ID will be stored here. Okay. Next salary value 4500. Next salary value 4500. So now is 4500 greater than root node or not? It will check. Is 4500 greater than 3000? Yes. It goes to the right side. Is 4500 greater than 4000? Yes. It will be placed at right side. But in the right side, it arranges in ascending order. So because of that reason, this 4500 will be placed here before 5000. In the ascending order, it will place. Okay. Next value is what? 1200. Is 1200 greater than root node or not? It will check. Is 1200 greater than root node? No. It is less than. Less means where it will be placed? Left side. Again, it compares with 2000. Is 1200 less than 2000? Yes. It will be placed at left side. Here it will be placed. So now 1200 will be placed at left side. So now 1200 will be placed here. Here 1200 will be placed. It's row ID. Next. So this will be placed at left side. Just a minute. Okay. So here 1200 will be placed. Next salary is 3000. Is 3000 greater than root node or equal? Equal. Equal means where it will go? Left side. Is 3000 greater than 2000? Yes. So it goes to the right side. So right side, it places the 3000 value. So right side, it places the 3000 value. So for our understanding purpose, I'm taking boxes here. So this is the box. Okay. Just a minute. So like this, it stores. One more box I'm taking. Okay. So in this, okay. So like this, 3000 will be stored right side here. Here right side 3000 will be placed. 3000, it's row ID. Next salary value is what? 4500. Observe carefully here. Next salary value 4500. So 4500 means it is greater than root node. It goes to the right side. 4000. Okay. 4500 is greater than 4000. It goes to the right side. But observe carefully here. 4500 value already there or not? Observe. Yes. So again this 4500 value will not be stored. Row ID will be stored. Value stored for how many times? One time only. Value will not be duplicated here. Okay. Next salary value is what? 3000. So 3000 means it is equal to the root node. So it goes to the left side. And it is greater than this 2000. It comes to the right side. Already 3000 value is there. Again value will not be stored. Its row ID will be stored. So with this, we can understand that how many employees are earning 3,000? 2 members. How many employees are earning 4,500? 2 members. So value will be stored only once, but its row IDs will be stored there. Next value is what? 1,000. Okay, 1,000 is less than root node. It comes to the left side, and less than 2,000 comes to the left side. And here it arranges in ascending order. So this 1,000 will be placed above of 1,200. Okay, and next value 1,500. 1,500 less than 3,000, less than 2,000. So 1,500 will be placed here. Next value 1,800 less than 3,000, less than 2,000. So 1,800 will be placed here. Okay, and the last value 1,200. 1,200 value already there. So just it stores row ID. So in this way, it creates the balance tree. Now balance tree is created. Observe here. Balance tree is created now. Okay. Now, for example, we are submitting the query like this. Select star from EMP where salary greater than 3,500. This query we are submitting. Try to understand here. So what is the condition here? Salary greater than 3,500. We want to retrieve the employee records who are earning more than 3,500. Now index is created. It performs index scan or table scan? Index scan. So in the table scan, what it will do now? See here. If index is not created, it performs a table scan. In the table scan, what it is doing? Observe. So we are writing condition as where salary greater than 3,500. Is this value greater than 3,500 or not? It is checking. Is this value greater than 3,500 or not? Is this value greater than 3,500 or not? Like this. Here total 11 values are there. So how many comparisons it will do now? 11 comparisons it will do. Okay. Whereas, so in table scan, 11 comparisons it is doing. Now observe the same thing we are doing index scan now. So when we use index scan here, when we submit the query like this, where salary greater than 3,500, we are writing. Where salary greater than 3,500. So what is the filter condition value? What is the filter condition value? 3,500. That compares with root node. Now is 3,500 greater than root node or less than root node? Greater than root node. It comes to the right side. So is it required to go to the left now? No. Half of the comparisons reduced or not? We have no need to go to the left side. We have no need to compare. Our set filter condition value is greater than root node. So it comes to the right side. Now it compares with 4,000. Okay. So is 3,500 greater than 4,000 or less? Less. Less means where it will go? Left side. That compares here. Okay. Is 4,000 greater than 3,500 or not? It is comparing. Okay. So is this condition true? Yes. So here row ID is there or not? Yes. So it goes to this row ID. It goes to this row ID and picks the record directly. Just like in the textbook, you are referring the index, you are referring chapter name, you are referring page number, you are going to that page number. In the same way, when you are retrieving the data, it is using B tree. It is comparing with root node. Okay. So 3,500 is greater than 3,000. So it is coming to the right side. 3,500 is less than 4,000. It is coming to the left side. So that is comparing here. Okay. So here row ID will be identified. Next. That goes to that row ID and picks the record. Next. From here, it travels to the next leaf node. Okay. Again, it compares. 4,500. Is it greater than 3,500? Yes. Okay. Here, how many row IDs are there? 2 row IDs are there. So it goes to 2 row IDs. So this is one 4,500 row ID. and this is another 4500 row ID. It picks these records now. Next, another value is there. Is 5000 greater than 3500? Okay, yes, condition true. It goes to this 5000 row ID, okay, and picks that record. Where is 5000? Here. This record will be picked. So, how many comparisons it is doing? Maximum, okay, 1, 2, 3. Okay, maximum 3 comparisons it is doing. Okay, so maximum 3, or if you count this root node comparisons also, maximum 5 comparisons it is doing. Okay, so less comparisons it is doing here. Okay, so automatically performance will be improved. So in the tree terminology, this one is called root node. We are calling this one as the root node. This 3000, this one we are calling as the root node. Whereas these last nodes are there. These are called leaf nodes. These are called leaf nodes. So here these leaf nodes are important to us. Okay. So these leaf nodes are very important here. Okay. So what leaf node holds? Leaf node holds value and row ID. Leaf node holds what? Value and row ID here. Leaf nodes are important here. And these are the intermediate nodes. Middle nodes we are calling as the intermediate nodes. So how index will work, to get some idea, we discussed this. Okay. So like this, implicitly one B tree will be created when we create the index. So now observe. So what is index? It is one database object. Why we are using it? To improve the performance of data retrieval. The only advantage we are getting is it improves the performance of data retrieval. So to retrieve particular record in table faster, we use this index. This index we create on the columns. On which columns we create? The columns which we frequently use in the where class. So in the where class, based on which column we are retrieving the data, on that column we create the index. So when we submit the query to the Oracle, it may perform either table scan or index scan. When it performs table scan, if index is not created, it performs table scan. If index is created, it performs index scan. Index scan is faster. To create the index, this is the syntax. Create index, index name on table name, which column. So here, index is not created. When we submit this, it is performing table scan. After creating this index I1, it is performing index scan. It works faster. When we create the index, implicitly one B tree will be created. Balanced tree will be created. Okay. So like this, one balanced tree will be created. So based on this balanced tree, okay, in the leaf nodes, it contains values and row IDs. Based on our filter condition, it identifies the value and it identifies the row IDs. It goes to those row IDs and picks the records. So this is index scan. Now listen. Types of indexes. Types of indexes. So there are two types of indexes. One is B tree index and another one is bitmap index. One is B tree index, another one is bitmap index. So B tree means in B tree index, this B tree will be created. So like this one B tree, balanced tree will be created. If B tree is created, that is B tree index. If B tree is not created, that is bitmap index. So in B tree index, subtypes are there like simple index, composite index, Okay, and unique index. Okay. One more is function based index. So these four are the subtypes of the B tree index. And second one is bitmap index. So what is B tree index, sir? If B tree is created, when we create the index, those indexes we call as B tree index. If B tree is created, okay, if B tree is created when we create the index, then it is called B tree index. And this B tree index can be also called as normal index. So if B tree is created when we create the index, then it is called B tree index. This B tree index can be also called as the normal index. This B tree can be also called as the normal index. So if B tree is created, that is called B tree index. If B tree is not created, that is bitmap index. If B tree is created when we create the index, then it is called B tree index. Subtypes are simple index, composite index, unique index, function based index. These are the subtypes. So it has subtypes. They are, first one is simple index. Second one is composite index. Okay, third one is unique index. And fourth one is function based index. So these four are called B tree indexes. Topic is very easy. So simple index means very simple. If index is created on one column, I already told, index can be created on one column or multiple columns. See, index can be created on one column, or index can be also created on multiple columns also. So index is created on one column, or index can be also created on multiple columns also. If index is created on one column, that we are calling as the simple index. If index is created on multiple columns, that we are calling as the composite index. That's it. If index is created based on one column, that is called simple index. If index is created based on multiple columns, that is composite index. Till now we created one index. So just now we created one index on salary column. Is it simple index or composite index? Simple index. Why? On one column we are creating it. So it is called simple index. So simple index means if index is created on one column, then it is called simple index. If index is created on one column, then it is called simple index. For example, we are creating like this: create index name I1 on EMP table salary column. So this is called simple index only. Next, second one, composite index. So what is this composite index? See here. If index is created on multiple columns, then it is called composite index. So if index is created on multiple columns, then it is called composite index. So if index is created on one column, that is simple index. If index is created on multiple columns, that is composite index. For example, our frequent operation is retrieving data based on department number and job. For example, assume. Okay. So I'm creating one table here from the existing table EMP. So create table EMP1 as select star from EMP. So from the EMP existing table, we are creating the new table. Okay, new table is created. Now, our frequent operation is retrieving data, select star from EMP, where department number equals to 20 and job equals to manager. So our frequent operation is retrieving based on department number and job. This is our frequent operation. So 20th department manager records, 10th department clerks records, 30th department salesman records. Okay, 10th department manager records. So like this, every time based on department number and job, we want to retrieve. That is our requirement. So to improve the performance on these two columns, we create the index. So now if we submit this query, as of now, it performs table scan or index scan? Table scan, because index is not created. Now we are creating the index on these two columns. How can we create the index here? Create index name I2 on which table? On EMP1 table. On EMP1 table. So just now we created EMP1 table. So on EMP1 table, EMP1. Okay, on which columns? One is department number and another one is job. Here, order is important here. Order is important. If you write department number job here, based on department number, B tree will be created. Based on this department number, B tree will be created. If you write like this, EMP1 job comma department number, based on job value, B tree will be created. So that's why here order is important. Okay. So whatever the first column you give, on that B tree will be created. Okay. So I am giving first column as department number here. Based on department number, B tree will be created. If you give first column as job here, job department number, based on job, B tree will be created. Okay. So now index is created on two columns. This is called composite index, because index is created based on two columns. So index is created now. The same query we are submitting now. So select star from EMP1, where department number equals to 20 and job equals to manager. This one we are submitting. Now is it perform table scan or index scan? Index scan it performs. Okay. And listen carefully. Before Oracle 9i version, if we submit this query that performs index scan, okay. For example, I am submitting department number. Department number equals to 20. Now, is it perform table scan or index scan? Means it will perform index scan only. Because we are creating index like this. Now, index is created based on the department number. So, if you use on both columns, index is created. Try to understand. On both columns, index is created. So if we use both columns in the condition, it will perform index scan. And when we create index like this, here B tree is created based on department number. Here B tree created based on department number. So because of that reason, if I submit department number equals to 20, then also it is performing index scan here. Index created based on, B tree created based on department number. So when I retrieve data through the department number, it is performing index scan. When I use both conditions, it is performing index scan. But when I use job condition here, so for example, I'm writing job equals to manager. Now, before Oracle 9i version, the situation was it performs table scan only. Okay. So observe carefully here. Here index is created on two columns. Now B tree will be created based on the department number. Based on department number, B tree is created. So if you use 2 columns, okay, it is performing index scan. If you are using 1 column department number, okay, it is performing index scan. But if you are using job, it is performing table scan here. This was the situation before Oracle 9.9. But from the Oracle 9.9 version onwards, okay, same queries from Oracle 9.9 version onwards, what is happening? Observe. From Oracle 9.9 version onwards, they divided index into 2 types. One is index range scan, another one is index skip scan. Index range scan, index skip scan. So here it will perform index range scan here. If we use 2 columns, if we use 1 column, it will perform index range scan here. Okay. If we use this second column, job is the second column here. If you use the second column, so then also it uses B tree. But first value will be skipped, second value will be checked. First value will be skipped, second value will be checked in the B tree, in the leaf nodes. So this scan we call as index skip scan. First value will be skipped, next value will be checked. That scan we are calling as the index skip scan. First value is skipping, department number value skipping, job value checking. That is called index skip scan. So this introduced in the Oracle 9.9 version. Let me show it. Observe. So I am retrieving data. Observe here. Create. Sorry. I want to create EMP1 table. So if any table is there with the name EMP1, I'm dropping that one. I'm creating a new table EMP1. Create table EMP1 as select star from EMP. Try to understand here. So EMP1 table is created. Observe. So select star from EMP1. EMP1 table is created. So EMP1 table is created. Now our frequent operation is retrieving data based on department number and job. So we are writing like this. Select star from EMP where department number equals to 20 and job equals to manager. This query we are submitting. So now is it perform table scan or index scan? Table scan, because we didn't create the index on these columns. On department number, job column, index is not created. It performs table scan. Observe here, complete table accessed here. And filter condition is department number 20, job manager. Okay. So complete table it is accessing here. So table scan it is performing. Now we want to improve the performance. So we are creating index on 2 columns. So whenever our frequent operation is retrieving data based on 2 columns, then only create this composite index. Otherwise don't create. If based on 1 column, create simple index only. 2 columns if we are using in the where condition, at that time only, it's better to create composite index. So create index I2 on which table? EMP1. Which columns? Department number column, comma, job. So now index is created. Observe. So now observe here. I am submitting the same query now. Select star from EMP where department number equals to 20 and job equals to manager. Observe here. So sorry. Sometimes it may not identify the indexes. Sorry. Here we retrieve data based on EMP. I'm sorry. EMP1, right? EMP1. So observe here. See what it is telling? Index range scan. So table name is EMP1, not EMP. So select star from EMP1 where department number equals to 20 and job equals to manager. We are writing on department number and job. We created the index I2. Because of this reason, it is performing index scan here. So which index it is using? It is giving index name also I2. So it is going to the I2 it is identifying the value in the leaf nodes. Values are there, row IDs are there. It is by using values, it is doing comparison. With that, it is identifying the row IDs. It is going to that row ID and picking the record. So here table is accessed by using the index row ID. So when we submit the query, index scan it is performing by using I2. So in the leaf nodes, values and row IDs are there. Their values comparison will be done. It identifies the row IDs and picks the rows. Okay. So if we use two columns here, index scan it is performing, index range scan it is performing. Now, for example, I am submitting one column here. So generally, when we want to retrieve data based on two columns, we use composite index. Suppose if we use one column here, which scan it performs, we want to test. So where department number equals to 20, I'm writing. So B tree created based on department number. So it is performing, EMP1, where department number equals to 20. What it is telling? Index range scan. Okay. So with this, we can understand that if we use one column also, one column department number also, it is performing index range scan only. If we use both columns, then also it is performing index range scan only. If we are using two columns here, it is performing index range scan. If we are using one column here, department number 20, then also it is performing index scan here, index range scan. For example, we are using second column. So select start from EMP1 where job we are using. Job equals to manager we are using. So now observe here what it is performing. Index skip scan it is performing. So in the leaf nodes, data stored like this. 10th department, okay, clerk, row IDs. 10th department, manager, row IDs. So like this, data is stored. Okay, and 20th department, clerk, row IDs. So like this, first one is department number, second one is job. Okay, so this first value will be skipped. Second value will be checked in the leaf nodes. So that's why we are calling this as the index skip scan. First value will not be checked. Second value will be checked. So it identifies the row IDs and goes to those rows and picks the records. So this is called index skip scan. So before Oracle 9i, this was not available. It was performing table scan if we use second column. If both columns, index scan. If first column, index scan. If we use second column, before Oracle 9i, it was performing table scan. But from Oracle 9i version onwards, it is performing index skip scan. So this is about composite index. And next one is unique index. So very, very simple. If index is created based on one column, that is what? Simple index. Here, based on salary, we created simple index. Composite index means if we create index based on multiple columns here, that is composite index. Next, unique index. This unique index will be created on a column which is having unique values. For example, employee name is there. Okay, first employee name is Ravi. Next employee name is Kiran. Next employee name is also Ravi. Okay, and next employee name Amar. Next employee name is also Kiran. So like this, here names will be duplicated. Many employees with the same name Ravi. Many employees with the same name Kiran. So name will be duplicated here. On this column, can we create the unique index? No. The column which contains unique values, on them only we have to create it. Okay. For example, if we are taking department name in the department table, we are maintaining department name. So this department name will be stored only once. Accounts department. HR department, sales department. So every value will be stored only once. On this department name is having unique values. If our frequent operation is retrieving data based on department name of department table, we create this unique index. So the column which contains unique values, on that we create this index. So if index is created on a column which have unique values, then it is called unique index. Okay, so if index is created on a column which have unique values, then it is called unique index. Okay, for example, observe, we are creating one index I3 on department tables, department name. Okay, so if now we want to create the unique index. So to create the unique index, here we have to write unique, create unique index. So the advantage here is, in the future, even if you are inserting any duplicate value in this department name column, it will not accept that duplicate value because of this unique index. So see, in a column, now observe, I am creating this index, create index name I3 on which table? Department tables. Which column? Department name column. So now index is created. Okay, my frequent operation is retrieving data based on department names. So I'm retrieving like this. Select star from department. Where department number equals to 20. Observe here. Here it is displaying department number 20 record. Okay. So sorry. I want to create unique index here. So unique index I4 I am giving. Unique index I4 I am giving. So already indexed. Let me drop index I3. Okay. So I am creating unique index. Observe. Create unique index name. 2 semicolons are there. Okay. So what it is telling? Index is created. So we typed 2 semicolons. That's why it was giving error. So observe here. Create unique index I4 on which table? Department table, D name column. So if the column is having unique values, okay, on that we create the unique index. So department name is having unique values. So we are creating the unique index here. So now observe, we are retrieving data based on the department number, based on department name. I'm giving department name as sales department. So which scan it is performing? Index unique scan it is performing. Observe here, index unique scan it is performing. So it is using I4 index. Just now we created this I4 unique index. Okay. So that unique index it is performing. So in the future, if you insert any duplicate value here, it will not accept. You can observe here. See, insert in which table? Department table. I'm inserting the values here. 50. Already sales department is there. Again, we are giving sales department. Okay. So some place location name I am giving. Okay. Observe here. Insert into department values. Values. Okay, see here. What it is telling, observe. Insert into department values. Already sales department is there in the department table. Select star from department. In the department table, already sales department is there. 30th department name is sales. Once again, we are trying to insert sales department here. It is telling that unique constraint violated, but we didn't create any unique constraint. We created unique index. I4 is restricting. Observe here. So the benefit with unique index is, if you create the unique index, in the future, that will not accept the duplicate values. So you can maintain the unique values. So we can maintain unique values in a column by using 3 ways. We can maintain unique values in a column by using 3 ways. What are those 3 ways? First one you already know. If you want to maintain unique values, okay, for example, employee number should not be duplicated. 1, 2, 3, 4. If we again give, that should not accept. To maintain the unique values, okay, which constraint we can use? Primary key. Okay, or can we use unique constraint? Yes. Okay, and can we use index here? Yes, we can use index also. Unique index also we can use. So primary key concept we can use, unique concept we can use, or unique index also we can use. So actually, when we create a new table, listen carefully. When we create a new table with primary key, implicitly a new index will be created. When we create a new table by using the primary key, implicitly a new index will be created. Implicitly a new index will be created using constraint name. Using constraint name, one index will be created here. That's it. So when we create a new table with primary key, implicitly a new index will be created by the Oracle with constraint name. For example, check here. I am creating a new table. Create table. Table name I am giving as demo. First field name I am giving as F1. Number type I am giving. Constraint name. So constraint name I am giving as CCC1. Constraint name I am giving as CCC1. And I want to apply primary key. Second field is F2. Number data type I am taking. Varchar 2 type I am taking. So if we create like this, if we create the table with primary key, implicitly one new index will be created with which name? CCC1 constraint name. You can check here. To see, I'm setting auto trace as off here. I'm setting auto trace off. Okay, now it will not display this table accessing this execution plan. It will not display. Execution plan will not be displayed if you set auto trace as off. So I am creating one table here. Observe. Before that, see the indexes information. Okay, so describe user indexes. So within 2 minutes, I close the session. Please listen. Describe user indexes. So all tables information stored in user tables. All views information stored in user views. All constraints information stored in user constraints. Like that, all indexes information stored in user indexes. So here 2 columns are important here. One is index name. Another one is index type. So I am retrieving index name and index type. Observe here. So select index name, comma, index type. From which table? From which table we are retrieving? User indexes. So observe here, I1, I4, I2. Who created? We created today. Okay, what are the index types? Observe here, normal index. I already told B3 index can be also called as normal index. Today we created 3 indexes. Those are normal indexes, B3 indexes only. I1, I4, I2, last 3. Last 3 today we created. These are the B3 indexes. B3 index can be also called as normal index. This is the index type. But observe here, these indexes we didn't create. Observe, these indexes we didn't create. Okay, but indexes are created because if we create the table with primary key, implicitly one index will be created on that primary key column. So for primary key column, we have no need to create the index explicitly. Remember this point. For primary key column, we have no need to create the index explicitly. When table is created with primary key, with constraint name, okay, implicitly one index will be created. Where is the proof? As of now, how many indexes are there? Observe, 7 indexes. Is there any CCC1 index? No. We are creating one new table now. If any table is there with the name demo, okay, I'm dropping that one. We are creating the new table demo here with the primary key. So with primary key, we are creating the table. What it is telling? Table created. So in this table, F1 is primary key. On this F1 column, implicitly one index is created. That index name is what? CCC1. If you want to see that, what we have tried here? Select index name, comma, index type. From which table? User indexes. User indexes. Observe here. So CCC1 created or not? Yes. So previously how many indexes were there? 7. Now how many indexes are there? 8. One new index is created on primary key column. That is also B3 index. So because index is created on one column, F1. On F1 column it is created. On primary key column, we have no need to create the index. On non-primary columns, we have to create the index. That's it. So now I'm stopping the session here. So how many types of indexes are there? 2 types. What are those? B3 index, bitmap index. B3 index can be also called as normal index. What are the subtypes in the B3 index? Simple index, composite index, unique index, function based index. What is this simple index? Simple index means if index is created based on one column. Composite index means if index is created based on more than one column. Okay, more than one. If index is created on multiple columns, that is composite. If index is created based on one column, simple. So what is unique index? If we create unique index on the column, that column cannot accept the duplicate values. Okay, that is unique index. Okay, and tomorrow we discuss this function based index and bitmap index. And tomorrow I finish this topic. In the first half an hour, I finish this topic. After that, we discuss another topic, sequence. Okay, another database object, sequence. Okay, so in the next week, by Tuesday or Wednesday, I try to finish this SQL. And in the next week, we start PLSQL. Okay, thank you everyone. See you tomorrow.